day guys, today we'll still be taking chemistry but another topic, which is solubility. Water and solubility are somehow related, so from our knowledge on water, so we need to know more about water and solubility. What is solubility? Let's just say something that is soluble. Let's come down to layman language. Something that is soluble. What do you mean by soluble? Something that can dissolve. Something that can dissolve in another thing. So now let's give the definition of solubility. Solubility can be defined as the amount of solid at a particular temperature that can dissolve in a solvent at that given temperature. I think you understand. Solubility can be defined as the amount of solid at a particular temperature that can dissolve a particular solvent at that same temperature. So please, when you are defining solubility anywhere, let temperature be your key point. It is a key definition for those taking SSCE. Please remember to include at a particular temperature, because temperature is one of the important factors that affect solubility. So now let's move to the types of solution we have. What is a solution? First of all, solution is any compound or any mixture that contains a solute and a solvent. So we have solute plus solvent. Solvent equals solution. So solvent, when we use water, I told you water is the universal solvent. So a solvent can be a liquid, can be anything, but the most recognized solvent is the liquid. So let's say our solvent is a liquid. Our solvent is a liquid. Then our solute can be a solid. So now let's give an example. They will give us what? Solution. So now let's give example of a solute. The solute here is salt and the solution is water. And it will give us what? Salt. Sorry, the solute here is salt and the solvent is water. And this is what? Salt water. Salt water. So salt water is what? Solution. Salt plus water gives a solution of salt water. So now let's move on to types of solution. Types of solution. We have two types of solution. We have the true solution and the false solution. Types of solution. One is true solution. Two is false solution. What do you mean by true solution? True solution is an homogeneous mixture of any substance. What do I mean by homogeneous mixture? That means the mixture of two things that was uniform. Homogeneous solutions are solutions that are what? True solutions are solutions that are homogeneous and are what? They are uniform. That means the solute and the solvent, they mix evenly. You won't even know that okay, something is dissolving into something when the solution is formed. Example is our salt water, like I said earlier. When you mix salt and water, you won't be able to say, oh, this is the salt and this is the water. This is an example of true solution. True solution have particles, but the particles are very small. They cannot be seen with our naked eyes unless with the use of microscope. So these small particles in true solution are called crystalloids. Crystalloids. These are examples. These are the particles in what? True solution. They are very small. They can be called crystalloids. They are not visible to our naked eye. So now let's move to false solution. Definitely false solution will be what? Heterogeneous mixture. A mixture that is not uniform. That the particles in it can be seen with our naked eye. We have two types of false solution. We have the colloid and the suspension. Colloid and what? Suspension. These are the two important examples of what? False solution. When we say colloid is a solution that contains a dispersed phase and a dispersed medium. A dispersed phase. Dispersed phase and a dispersed medium. What do I mean by this? Examples of colloid. Example of colloid is hot water plus starch. Hot water plus starch looks like jelly when it is mixed. It is somehow thick. This is an example of colloid. Our protoplasm, the protoplasm in our cell also is an example of colloid because it is what? It it is mixed, it is heterogeneous. The particles in it can be seen with our naked eye. That is why it is called a colloid. And when we have suspension is also an heterogeneous mixture, or it is not really. Example of suspension. Let me give an example of suspension before I give the definition. Example of suspension is our mixed mark. Our mixed mark is a mixture, but when it is standing, you will see what is dissolved into one another. You will see the dispersed phase and the dispersed medium in suspension. Like another example is mud water or a muddy water. When you bring a muddy water, when you put it down, when you settle it on standing, after some minutes you see the water up, you see the sand down. That is an example of suspension. That is where suspension looks like. It is a mixture that is not homogeneous, it is not evenly combined. That is why you get to see the things that are contained inside the particles whenever it is standing. So please note, a very important characteristic of suspension which colloid do not have is sedimentation, is that they settle while standing. And another thing is that suspension can be separated by what? By filtration. For example, when you have your mud water, when it stands, you get to have the sand under and the water will be up. So you can easily filtrate the sand away from the what? You can easily filtrate the water away from the sand. It is a very good difference between colloid and suspension. So now let's move to examples of suspension we have. The first example, let me draw a table of the dispersed phase and the dispersed medium. So dispersed phase, dispersed phase, and dispersed medium, and the outcome, like solution they will give us. So when we have liquid into another liquid, there is nothing it will give us than emulsion. Albumen. I think we know what albumen is. These are the solutions it will give us when liquid is dissolved into another liquid. When liquid is dissolved in, when liquid is dissolved into a solid, when we have a liquid and it is dissolved into a solid, what will be the solution? We will have a liquid, let's say water, when a solid is dissolved into a liquid, so let's say the example of the solid we have here is our hot water starch, and we have the liquid to be hot water. So when the solid is dissolved into the liquid, definitely we will have our starch, our jelly, our glue. This is an example of solution that will be formed when a solid is dissolved into a liquid. When a gas is dissolved into a solid, when our gas is dissolved into a solid, we will have smoke or amazon. So when liquid is dispersed in solid, we have haze or fog. When we have little droplets of water in the atmosphere, that's what we know as haze or fog. So another example is when we have gas into a gas, we have aerosol. Our famous example is aerosol, like our perfume and all. Another example, when we have liquid in gas, yes, liquid in gas can also be our normal perfume. For example, your perfume in the house, when you spray it on your hand, it comes out in the form of gas, but when it comes on your hand, it is what it turns to liquid. It's because liquid is dissolved into that gas. So these are the common examples of colloids that we have. Emulsion is colloid, and the most important colloid that is present is what? The protoplasm, which is the living component of the cell of living organisms. So that is all about types of solution. Let's move to the next. We also have some other types of solution. We have saturated solution, undersaturated solution, and supersaturated solution. So We also have another type of solution. We have the saturated solution, undersaturated solution, unsaturated rather, and what? Supersaturated. What do we mean by saturated solution? A saturated solution is a solution that is at equilibrium. What do I mean by that? Whereby the solute and the solvent, the dissolved solute and the undissolved solvent, they are in equilibrium. That means the solution now have enough of solute, the solvent has dissolved enough solute and it can no longer dissolve more. But when the temperature of this kind of in a saturated solution, what do you mean by saturated? Something that is filled, something that is no longer hungry. When you finish it, you say, wow, I'm saturated. That means you are no longer hungry. So nothing can come into you again. That is the example of saturated solution, whereby the solvent and the solvent has dissolved enough solute it can at that temperature. They might still be undissolved solutes though, but the solvent has done the one it can at that temperature. It has taken the one it can take in at that temperature. So there is now an equilibrium between the undissolved solvent and undissolved solute. I hope you understand that. Unsaturated solution. This is a type of solution that can still take more, that can still eat more. Like someone that is hungry, the person can still eat more. We have less, so the solvent can still dissolve more solute at that temperature. When the temperature is increased, the solvent can still dissolve more solute in an unsaturated solution. When we move to supersaturated solution, this is shown as overfed himself. He has overeaten. It is now supersaturated. This is a solution that the solvent has taken in more than the solute it can dissolve at that temperature. So the solvent is now unstable. It's just like human being. When you're eating and you are very uncomfortable, when you're eating, you overfed yourself, you'll be very uncomfortable. So that is what it is about supersaturated solution. Supersaturated solution is a solution that is unstable. Saturated solution is a solution that is at equilibrium, while unsaturated solution is a solution that still needs more to come into it. So that is all about all the forms and types of solutions that we have. Please let's note an important formula in solubility. To calculate the solubility of any substance, solubility of any substance equals to what? N times 1000 over volume. N times 1000 over volume. This is the formula of solubility. And N is equals to number of moles. And number of moles equals to what? Mass all over molar mass. Molar mass. So we can say the formula for solubility is F equals to mass over molar mass times 1000 all over volume. I hope you understand. Mass over molar mass times 1000 all over the volume of the substance you want to dissolve. This is the universal. Let me just say this is the shortcut formula for calculating the solubility of any compound. So that is all about this formula. So now let's move again. In solubility we have water of crystallization. So let me just give you the short formula to calculate water of crystallization. X is equals to water of crystallization so definitely X is equals to H minus A all over M all over 18A. Let me tell you what all these things, what they stand for. H is equals to mass of hydrated water, mass of the hydrated compound. A is equals to mass of the anhydrous compound. M is equals to the molar mass. A, like I said, so this is the meaning of all the parameters, and S is equals to water of crystallization. This is the short formula in calculating water of crystallization of any substance. So now let's move to some substances and things that can be used to dissolve them. Substances and things that can be used to dissolve them. Here we have oil. So substances and stuff that can be used to dissolve them. We don't need a table actually So let me just see. When you have oil stain on your cloth, what can dissolve oil stain? You have kerosene, petrol, diesel. These are stuffs that can make oil, that can dissolve oil. So when you have oil stain on your clothes, when kerosene or petrol is poured on that cloth, it will spread the oil. It will make it have a large surface area. I hope you understand. It will make the oil have a large surface area, and when it does, gradually when it is spreading, the oil stain will start to disappear. I hope you understand it. When you have oil stain on your clothes, the oil will be concentrated on the part, but when kerosene or petrol is added, it will make the what? It will make the oil stain begin to spread. It starts having large surface area. So when it starts spreading, the stain starts to disappear. That is what it is about oil stain. Another one is coffee stain. Coffee stain. What can remove coffee stain is borax solution. Borax solution. The solution of borax is what can remove coffee stain. So another thing is gold stain. Gold stain can be removed by aqua regia. Aqua regia. And aqua regia is a combination of NH3 and HCl. That is the combination. That is what's composed of what? Aqua regia. NH3 and HCl. The next thing is ethanol. Ethanol can be dissolved. Sorry, the next thing is iodine. Iodine can be dissolved in what? Ethanol. The process of dissolving iodine in ethanol is called what? Tincture process. Tincture process. The process of dissolving iodine in ethanol is called the tincture process. So another thing, what else can we dissolve? Okay, we dissolve sulfur in carbon disulfide. This is very important in vulcanization of rubber. Sulfur dissolves in what? Carbon disulfide. That is CH2, carbon disulfide. This is used in what? Used in vulcanization of rubber. You know what they call vulcanizer. So vulcanization of rubber. What is the essence of vulcanization of rubber? The essence of vulcanization of rubber is what? To make, like when you take a tire to a vulcanizer's place, what do they do to it? They just make it bigger when it becomes less. So definitely the carbon disulfide is doing what? Is increasing the surface area of the tire by making it bigger. I hope you understand this. So now, these are common things and substances that can be used to dissolve them. What is actually solubility? Solubility is just when two substances meet and one has the power of making the other have a large surface area to volume ratio. So now there is this law in solubility that says polar dissolves polar, polar solvent dissolves polar, while non-polar solvent dissolves non-polar substances. This is just the law in solubility. It is the opposite of the law in electrolysis that says unlike charges attract, like charges repel. But in chemistry, the law is polar dissolves polar. That is like dissolves like, unlike dissolves unlike. I think you understand. So definitely water has an hydrogen bond, so it will dissolve an alkanol because what? An alkanol has the OH functional group. I hope you understand. That is what we mean by polar dissolves polar. So water is a polar solvent and it dissolves what? Any polar substance. And non-polar solvent dissolves what? Non-polar substances. So even the other time, look at when we were giving examples. We said iodine will dissolve in ethanol. From a layman, from the organic chemistry, iodine will dissolve in what? Ethanol. Why? Because they are both non-polar substances. And sulfur will dissolve in carbon disulfide because they are both like charges, so they can dissolve each other. Like dissolve like, unlike dissolve what? Unlike. So polar dissolves polar, non-polar dissolves non-polar. There is no partial in it. So water is a polar solvent, so it dissolves polar substances. So now let's move on to factors affecting solubility. Factors affecting solubility. We have one, factor of temperature, and another is what? Factor of pressure. So to be divided into two, the factor of temperature on gases and solid. So let's talk about gases first. We use a very good example, something we see around us. You know your Coca-Cola, Coke, let me just say, is a carbonated drink. Why do they call it carbonated drink? It is called carbonated drink because what? It contains carbon, CO2. If you've done carbon and its compounds, you know that carbon oxide, which is CO2, has a refreshing taste. For this, it is used to produce carbonated drink because of its what? Refreshing ability. So, and CO2 is a what? Is a gas. Everyone knows CO2 to be a gas. So how does temperature affect the solubility of CO2 that is a gas? When you have your Coke, okay, let's say your Coke, you just bought it from the person said, maybe from the pack, a pack of Biggie Cola or a pack of Coca-Cola. Then what temperature will it have? It is hot. Let's just use that statement that it is hot. And something that is hot has an higher temperature. So when you take it, for example, take that Biggie Cola the way it is before putting it inside food, it's not even cold at all. Hot Biggie Cola. Please, how will you feel? Your stomach will first of all get scattered. You just feel miserable by taking something like that. Because now, another case study, take the Biggie Cola, put it in your freezer or your fridge or your refrigerator or your chiller, anyone you can put it in, that can reduce the temperature. I hope you understand. When the temperature is now reduced, the Biggie Cola becomes what? It becomes cold. Take this cold Biggie Cola and compare it to when you are taking that hot Biggie Cola. You will feel that the feeling is different. You will feel refreshed. It will even taste sweeter when you are taking the cold one than when you are taking the hot one. Why is it like this? It is because decrease in temperature will give increases solubility of gases. Decrease in temperature, let me just tell you, increases solubility of gases. So decrease in temperature increases the solubility of gases. That is why when you put your Coca-Cola inside the fridge, the temperature gets reduced, and what will happen? The solubility of the carbon dioxide will increase. The carbon dioxide will start to dissolve very well, so it will make the Coca-Cola refresh. I hope you understand. It will refresh the taste of the Coca-Cola because one of the properties of carbon dioxide is to give a refreshing taste. So when it is there, when the temperature is increased, when the solubility of carbon dioxide starts to increase, that is when your Coca-Cola will now have a very good taste, a refreshing taste, a sweet taste. Let me just say. I hope you understand this. I hope you get this case study. As I said, decrease in temperature increases the solubility for gas. But for solid, it is otherwise. It is different for solid. Example of a solid, let's take our Danone. When you want to prepare tea, take your Danone, pour it inside the plastic, then pour cold water. You feel like, why is this like? It won't dissolve very well. Or take your Milo. Milo is better. I think Bonvita is the boss. Let's just pour Bonvita and pour cold water on Bonvita. You just feel like everything will just be crumbled. It won't have a nice, it won't be smooth. Yeah, you have some of the solvents, you have them, you see them, they will be very rough. It won't give us a true solution. We have a false solution, and it won't even taste nice. But take an example of using hot water to prepare tea, or at least hot water to first of all to first of all dissolve the Milo or the Bonfita or the Dano. One thing you notice is that it will dissolve fast. Another thing is it will be sweeter than using cold water at first. You might want to have a cold tea or whatever you want to have, but using hot water to dissolve those things at first to make it have a nice taste and to make it dissolve faster. So that is why increase in temperature in solution. Increase in temperature increases solubility of solid. So let's represent it in the formula. So temperature in solid is directly, so which one will be for solid, which one will be for gas? So this one is increase in temperature reduce solubility. So definitely we know that this one is for gas. So this is the proportionality sign, and here it is inversely proportional. So this starts for temperature. So when temperature is increasing, this one is what decreasing. So then even this taxes, please note it for your physics, it will help you a lot. When anything is inversely proportional, it means this one is increasing, this one is reducing. When anything is directly proportional, it means both are increasing at the same time. So this one is definitely for gases. So when there is increase in temperature, there is what? A decrease in the solubility. And for this for gases, for solids, when there is increase in temperature, there will be an increase in solubility. So that is all. And pressure also affects solubility. How does pressure affect solubility? Okay, let's say you have the former example I gave, or let me just use when you are mixing flour and everything for pop-off or whatever you guys bake. When you pour it together, you take your turning stick, apply pressure with the turning stick. When you are turning it, it will do what? It will increase the solubility of the pop-off, the flour, the donut, the yeast. I said donut, sorry. Flour, the sugar, the butter you are mixing together, because we are increasing the pressure, you are adding pressure with your turning stick, so it will increase the solubility of whatever you are. It will make whatever you are mixing mix fast. Let me just use that English. It will make it mix very fast because there is an increase in pressure. So increase in pressure also does what? It increases solubility. I think that is all we have to do about solubility. We've given the types of solutions, we've given the what factors affecting solubility, and so that is all. And thank you.